Today we're going to discuss how to graph the data from the Properties of Water lab. First, I want to take a short look at this diagram of water molecules. Water is composed of 2 hydrogen atoms and 1 oxygen atom. Notice in our model here that the oxygen is larger in mass and also is represented by red circles. Hydrogen atoms are smaller and represented by white circles. Oxygen, if you look at your periodic table, you'll see that it is on the right side. Elements on the right side of the periodic table are more electronegative than atoms on the left side. Hydrogen is the very first element represented in the periodic table. It is on the left side at the very top. As a consequence, oxygen has a slightly negative charge, and hydrogen has a slightly positive charge. This is what causes the asymmetrical shape in a water molecule. Because there is a differential charge on each side of the molecule, this molecule is said to be polar. Polar molecules have attractive forces. The hydrogen atoms are attracted to the oxygen atoms in nearby water molecules. You are going to experiment and understand 4 unique properties of water in this lab. For example, cohesion is the attractive force between water molecules. Adhesion is the attractive force between water molecule and another substance, for example, the glass in the capillary tube. So let's take a look at the anatomy of a graph. First, let's focus on things that are written in blue. The horizontal axis is called the x-axis. This is where the independent variable should be represented. The independent variable is something that you apply to the experiment, the treatment, and the levels of the treatment. The independent variable is not something that is responding in the experiment, it is causing the response. So in the example here, you'll notice that I've written tube diameter and time. You'll be using tube diameter in the second activity for your x-axis and time in the x-axis for the 4th activity of the lab. Now let's take a look at the y-axis, the vertical axis. The y-axis is where the dependent variable belongs. This is the thing that you actually measure, the thing that you expect to be responding to the treatments of your experiment. So through hypothesizing, you will make a prediction about how tube diameter will affect the height of the liquid in the tube, and how time will affect the melting of liquids. Okay, now let's take a look at the green writing in this paper. So each dot there in the graph is called a data point, and it has coordinates. These coordinates explain exactly where the dot is on the x and y axes. If in Excel, we'll get there in a moment, if you hover on a data point, you'll reveal those coordinates. Now let's look at the bottom of the paper. You're going to be asked to calculate slope. Slope is the rise over the run. This is the change in the y-axis between 2 data points over the change in the horizontal axis, the x-axis. So another way to think about this is y final minus y initial over x final minus x initial. This is how we calculate all rates. Now I just want to point out one other thing. All the writing here in red does not automatically appear on your Excel graph. You are going to have to add that in. There should be a title to your graph, for example, tube diameter versus liquid height. There should also be labels on both axes so we know what data exists in this graph. You should be writing tube diameter or time in the x-axis, and then whatever measurement applies on the y-axis. So now let's see, how does the table and the graph relate? What is in a table? The table contains all of the data for your graph. So let's focus in for a moment. Notice here across the very first row are the names of the data. Okay? So we have tube 1, tube 2, tube 3. These will be duplicated on the x-axis of your graph. Now, running down each row, across each row, you'll see sample number 1, 2, and 3. Okay? And then in the empty spaces is where you will record the actual measurement. Okay? So the response exists in these 9 squares. Okay? But we can't just stop there, because there is a lot of variability in experimentation. Thus, you're going to be asked to collect data from 2 other students so that you can average the data. It is very simple to make averages in Excel, and one of the nice things about using Excel is that once you enter your formulas, you can slide that information across the rows and down the columns very easily. So now let's jump in and build this table in Excel. Okay, so I just opened a new book in Excel. Excel is part of your Microsoft Office. You can also use Google Documents, and there's a spreadsheet function there. But I'm going to focus on how to use Excel, as that is usually loaded to all computers. So in the very first row here, I have recorded the title of my graph, height of the liquid in the tube. That would be a sufficient title. Now in the second row, I've duplicated that handwritten graph or table you just saw. The sample number, the tube numbers, etc. Now notice that in these 9 squares, I've already made up data. Please do not copy this data. This is not real. I just made these numbers up for the sake of the example. So after you enter your data, you are going to make an average. Let's take a look at that. When you make an equation in Excel, you need to start the equation with an equal sign. Okay? This tells Excel that you want it to do some math. Okay? In the case of an average, you just have to write the word average. Now let me show you how this works. You write average in parentheses. Then you click on B3 and drag, while holding the click down, drag that box until you have collected all of your data. You can press enter now or add a parentheses. It will do it automatically for you. So there is our average of column B. Now this number is very messy. We don't want to leave this kind of number in our lab report. So look up to the top of your toolbar and notice these icons that increase or decrease the decimals. You can only have one significant figure more than the significant figures you entered to begin with. So it would be appropriate to leave this number at 7.3. Okay, so now we've made our equation. We only have to make it once. I'm going to click and hold on the bottom right corner and drag this equation across the row. Voila! Now you have created your averaged data. It is inappropriate to enter these raw numbers into your graph. They have not been what's called transformed. Okay? Also notice that these values in row 6 capture some of the variability in the data. They are an average of these different measurements. So now what do we do? Before we leave our table, let me show you one other fancy thing so that you can save a step when you're typing your lab report. You've made your table. It looks beautiful. It's electronic, but it doesn't have grid lines. So let's just select all of this. I'm holding and clicking to select. And then I'm going to go up to this box and I am going to add all borders. Okay, now I can actually select this table, do either Control C or use my right click to get a copy. Then I would go over to Word and paste that into my Word document to have a table pre-constructed. Don't forget to add in that title at the top of your table as well. Okay, back to Excel. So now we have all our data in Excel. What is the next step? We want to make a graph. And we only really care about this. We've only collected 3 data points with coordinates, okay? The coordinates, we'll see that play out in the graph. So I have held and clicked and selected these 3 boxes of data. I'm going to go up to Insert, Scatter. When you click Scatter, you can choose these different plots. So let's just choose one without a line. Okay. Okay, now let's take a look. Notice how if I hover on the data point, I get my coordinates, 1, 7.3. Now, you're not going to have 1 as your x-axis number. It's going to be the tube diameter on the x-axis, okay? So all you would have to do to represent that is modify this information here to actually describe the diameter of each tube. Okay, back to the graph. Now notice too that my x and y axes have no title, okay? So you'll need to add that in later on. This box is a key which explains what each data point is. You can simply remove it by right-clicking and pressing delete, or you can add a name in here. Call it something other than series. I typically just delete it, okay? Because having titles on your axes will impart that information. So here we have a scatter plot, right? It looks pretty much like a straight line. I am not predicting that your data will be in a straight line. This is just a simplified example. To make a trend line, you hover on the data point and right-click and select Add Trend Line. You have many trend line options. Let's just be simple about it and use linear, okay? And then down here you need to positively click Display Equation on the chart. This is going to be your slope. Close, and there you have it. This is your slope, 6.3. You can click in here and take those extra significant figures out. Okay, great job. You've made your graph. You can select the graph by choosing Copy or Control C. Go back over to your documentation of your lab and paste that right in. Wow, that looks very professional. Oh, here's one little trick I'll show you. If you don't want your boxes to touch each other, put a little space in there first. Now I can put my title at the top of my graph. And if you're savvy, you can use a text box to add in the titles for the X and Y axes. But I am perfectly fine with you writing it like this. Okay, I really hope this helps you out. Please contact me if you have any questions.